Hello everyone. In this video, we're going to take a look at the steps for solving multi-step equations. So first of all, it helps to know what is an equation. Well, if we take a look at example 1, example 2, those are equations, and we know they're equations because they have an equal sign. Equations are made up of expressions. The expressions are what you find on either side of the equation sign. So if we take a look at number 1, the expression y minus 7 plus 4y, that's an expression. And it describes a value. We don't know what that value is yet. We're going to figure that out in just a second. On the right-hand side of the equation, the expression is 13. So if we think about equations as being a scale, then both sides have to be equal. So whatever y ends up being, then when we plug that number in, this expression on the left-hand side is going to equal 13. And vice versa, 13 is equal to whatever this expression is. So when we're talking about solving an equation, what we mean is there's always going to be a variable in there, a y or an x. Usually we're going to see an x. But what that means is that we can find a number that we can substitute that x in for, and it will make that side of the equation equal the other side of the equation. And we're just looking for one number that's going to solve that equation. That's what that means. And it doesn't matter how complicated your expression looks. We can use these 3 steps over here to solve any one variable equation. Now, if there's 2 variables in the equation, then that's something completely different, and we're not going to see much of that this year, if any at all. So let's take a look. The first thing that you always want to do is you want to distribute. Okay, you want to distribute. And what that means is, what you're looking for is, are there parentheses in your equation? Well, if we look at example number 1, there are no equations. I'm sorry, there is an equation. There are no parentheses. So we don't need to distribute. But if we look at number 2, there is parentheses, and so we're going to have to distribute. And so that's really what you want to look for every time you start to solve an equation. Sometimes there's not going to be anything to distribute, so you can just skip that step. But sometimes there are things to distribute. So what does that mean? Well, distribute means we're going to take this number that is outside of the parentheses, and we're going to multiply it times everything that's in the parentheses. We're going to multiply. So we say 3 times a, that's just 3a. 3 times 5 is 15, but watch your sign. So it's going to be minus 15. And that's it. That's all you have to do to distribute. Now everything else in the equation is just going to drop down to this next line that we start, and nothing else changes. Okay, so all I did was just multiply this number outside the parentheses times everything in the parentheses. The second step, we want to combine like terms. Everything that's alike, we want to combine it. Well, what we mean by that is if we take a look at this expression here, 3a minus 15 plus 19, well, this expression has a term with a variable in it. That's this one right here. And it has 2 terms that are constants. A constant just means just a straight number, no variable with it. The negative 15 and the 19, these are like terms. They're both constants, so we can combine these. 3a, that's the only term with a variable in it, so we're not going to combine it with anything. So when we drop down to our next line, we can say 3a, and then we're going to combine a negative 15 and a positive 19. Well, positive 19 is bigger than negative 15. So what that's going to do is, if you say negative 15 plus 19, that gives us plus 4. And that's going to be equal to, this side doesn't change. There's nothing to combine over here. If there were anything to combine on this other side of the equation, we would go ahead and do that in this step, but there's The only thing that's on the side is just this -2. So it comes down. The third step is to isolate the variable. And this is really the last step. So to isolate the variable, we want to get rid of all the constants that are on this side of the equation. Well, the only constant that I have is +4. So to get rid of it, because it's +4, I want to subtract 4. Now remember, this is an equation, so both sides have to be equal. They have to remain the same value. Even though they might change, the numbers might change, the value is still the same. So if I subtract 4, if I take away 4 from this side, then I have to take away 4 from that side as well. So +4 minus 4, that goes to 0. -2 minus 4, that's going to give us a -6. And then what's left over, since the 4's cancel each other out, the only thing I have left is a 3a, so that's going to come down here. Now to isolate this term, we're still working on isolating the variable. Since a is being multiplied times 3, when you see a number and a letter right next to each other, remember that means that they're being multiplied. So a is being multiplied times 3. To get rid of a multiplied 3, I have to divide by 3. Remember, we got to do the opposite of whatever the operation is. So the opposite of multiply is divide. If I divide this side by 3, I have to divide this side by 3 as well. And when we divide by 3, those 3's cancel each other out, leaving us with just a, an isolated a, or the isolated variable. -6 divided by 3 is -2. So what this means is that if we go back up here to our equation, we can substitute the number -2 in for everywhere we see a, and when we solve that expression, it will be the same as whatever this side is equal to. So let's take a look at that. So if I say 3, then that's -2 minus 5 plus 19 equals -2. Let's see if that's true. So -2 minus 5 is -7 plus 19 equals -2. So 3 times -7 is -21 plus 19 equals -2. -21 plus 19, that's going to leave me with -2, is equal to -2. And that is correct. Now, let's take a look at example number 1. Remember, we said that the first thing we want to look at is to see if we have to distribute anything. Well, I don't see any parentheses, so I don't think I have to distribute anything. Okay, so we can skip down to to step number 2, combine like terms. Well, let's see. Looking at this, I've got a y term here and a y term there. Okay. So those are like terms because they both have a y in them. I can combine those. The -7, I can't combine with anything on this side of the equation because it doesn't have a y in it. So if I have one y here, remember, if you just have a constant by itself or a letter by itself, we can always put a 1 in front of it. That's not a very good one. There we go. So 1y plus 4y, that's equal to 5y minus 7 is equal to, nothing happened over here on the right side, so it's still 13. Next step, I want to isolate the variable. So since we have a subtract 7, I'm going to add 7. Whatever I do to one side, I have to do to another side, to the other side. I'm going to add 7 here. So that leaves me with 5y. 5y is going to come down. These cancel, so I've got 5y is equal to 20. 13 plus 7 is 20. Now, most often this is what you're going to end up doing. You're just going to have to divide by whatever number this is here. And the reason is because y is being multiplied times 5. We do the opposite. So opposite of multiply is divide. Divide by 5, and when I do that, those cancel out. Remember, though, whatever you do to one side of the equation, you have to do to the other to keep the values equal. So let's see, that leaves us with y right there. 20 divided by 5 is 4. And so to solve that, that's what we end up with, is the variable y is equal to 4. And just like we did over here on example number 2, if I plug that back in to the expression on the left, and then I solve that expression, it should equal 13. So let's try that. Let's see if I say 4 minus 7 plus 4 times 4 is equal to 13. Well, let's see. 4 minus 7 is negative 3 plus 16 is equal to 13, and that is true. So 16 minus 3 is 13 equals 13, and that is true.